Okay, so this is a video that's going to go through the study guide with you, okay? All right. Okay, so this first one, it says the data set, which is these ordered pairs, is what type of association or correlation. So you're going to see the word association or correlation. And remember, there are three types of correlation. You got a positive correlation, which means that the points are going up, okay? You have a negative association, which means that the points are going down. You have a no association, which means the points are scattered everywhere. You can't tell if they're going up, down. Are y'all okay with that? Okay. Mike, are you okay with it? Okay. They got positive then negative. No such thing. This you can't be both. It's either positive, negative, or no association. Okay. So in order to work out a problem as such, and I got to remember to give y'all graph paper tomorrow, you're going to have to graph these equations. Okay. The highest is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So first one, go over 9. Make sure y'all write this down, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then go up 10. And up here is 10. Are y'all okay with graphing points? What about you? Okay, good. Then we got 1, go over 1, and then up 7. 1, 2, 3, 4, 5, 6, 7. Okay, and I'm going to pause real quickly. Okay, so now we got this one. Now we're doing this one, 5 and 0. 1, 2, 3, 4, 5. And 0 means you don't go up or down. So that's my point. And then 6 over 1 more, and then up 1. And then 10, 10 is all the way over here, and then up 1, 2. And then 1 over 1, and then up 2. 9 is all the way over here, and up 1. What kind of correlation is this? Positive, negative, or no correlation? Okay. You think the points are going up? You said no, and Michael, what'd you say? You said no. Okay. It's a no correlation. What made you say positive? Let me pause. All right. So let's do number two. Okay. So with number 2, it says that Cassie decided to do an informal survey while riding the bus to school. She asked each girl her age and what shoe size she currently wears. Her result is shown in the scatter plot below. So X represents the age and Y represents the shoe size. Okay. All right. What kind of correlation is this? All right. So here again, since the points are increasing, it's not a perfect straight line. It's not going to be a perfect straight line because it is a scatter plot. Since it's increasing, this is going to be a positive correlation and it's going to be a linear association. Remember, it's not going to be a non-linear association again, okay? Because all this is saying, association is not saying that the line is perfect, okay? It's just saying that it's going in a linear fashion. It's going up, okay? It's not a perfect straight line, but it's going up. So this is not going to be your answer here, okay? Y'all okay? All right. Okay, number 3. The scatter plot below shows the number of bats in an area for the past 10 years. Okay. What kind of correlation is this? What kind of correlation is this one? Okay. And what kind of correlation do you think? Why do you think this is a no correlation? Okay. It's always going to be not scattered out, okay? It's all Okay, so for this one, you're going to graph both of the lines. Remember, this is uh, this equation right here. This is your slope. This is your y-intercept. Okay, so your slope is -3/4. So that means you're going to go down 3 and to the right 4. Start at 10. So go up here, start at 10, and go down 1, 2, 3, and to the right 1, 2, 3, 4. And go again 1, 2, 3, and to the right 1, 2, 3, 4. Down 1, 2, 3, and to the right 1, 2, 3, 4 will be over here. So this is the first line. And look, this line is a good line because most of the points are closer on that line. This other line that I chose, and remember the only reason why I chose these two lines to do is because these have positive slopes. And remember, this is a negative correlation, so there's no, it should be, your M should be negative, and these are positive. So it has to be either these. So let's do down 4 to the right 3 to check to make sure this is not it. So start at 10 again. Your B is 10. And this time you're going to go down 4. 1, 2, 3, 4. And over 1, 2, 3. 1, 2, 3, 4. And over 1, 2, 3. And when you draw your line, this line is the better line than this one. Okay. Number 5. Okay. So we got the scatter plot below shows the value of the boat over several years. X is the age of the boat, and Y is the value of the boat. The age is in years, and the value of boat is in thousands. Okay, so this is 10,000, 20,000, 30,000, 40,000, 50,000, 60,000, 70,000. Okay, all right, so we're doing a line of best fit again. All right, what kind of correlation is this? Positive, negative, or no correlation? Negative. Good job. This is a negative correlation. Since it's a negative correlation, your M is going to be a negative number, okay? So now we look at what our B is, because remember to write an equation, you have to have Y equals MX plus B. We know this number is a negative, so what would this number be? This is the starting amount or where the line will cross the Y-axis. Your line of best fit would be in here somewhere in here, okay? So maybe 60,000 is the start, somewhere in there is the starting amount. Okay, so let's look at our answer choices. You got 58,000, 60,000. All of these are pretty decent. Okay, all of them are pretty decent answers. They're so close together, so it's hard to know which one is which. So let's eliminate by slope. We're only looking at negative slopes. This slope is a negative, so that's a possible answer. And this slope is a negative, so that's a positive, a possible answer. These two we can eliminate because both of these have positive slopes. Okay, and this is a negative correlation. All right, so now we're going to decide which one is the better answer. This is going to be steeper because 8,000 is bigger than this 5,000. So we just have to really estimate a little bit better. Okay, so for here, if we do, let's see, every time it's going down about 8,000. So let's start at 60, let's start at 58 right here. Okay, that's the starting. And if it goes down from 58 to 8,000, it should be at 50. And look, it is at 50. Do you see how this is at 50? One is at 50. Okay. So that's a pretty good estimate right there that's going down by 8 and so on and so forth. So these two, if I do that and draw a perfect straight line through those 2 points, that's not too shabby. If I do 5,000, if I start here and I go down 5,000, that would be, this is 10, 5,000 will be right in here, the halfway mark a little bit above, and I draw a line that will look like this. So the first line is the better line. This is your much better line here. this is your much better line. All right. Did y'all see that or no? Okay. Michael, what about you? Are you okay? I can't hear you. Your volume is low. Let me see if it's my volume. Okay. So number 6. The scatter plot below shows the population since the year 2000. Okay, so this starting year right here is 2000. Yeah, baby. Oh no, you're fine. I'll pause. Okay, so now we're doing this again. We have a scatter plot below that shows the population of seals in the area since 2000. So the starting year, this year right here, since the starting year is 2000, so the 0 year is 2000, and then 2 years after 2000 is 2002, and 2004, 2006, 2008, then 2010, 2012. Okay. All right. So let's. It says based on the linear model, this right here, what does the slope represent? Remember, when you're trying to figure out what slope represents, remember the slope formula, the y's are on top and the x's are on the bottom, okay? Because it's y2 minus y1 over x2 minus x1. So your y represents the number of seals. Number of seals. That's how many seals there are. And your x represents the years. So it's the number of seals per year. So this is how you say that. Number of seals is on top, and this is per. So that's per, and what's on the bottom is year. So it's number of seals per year. That's how you read that. That's what the slope represents. So now we have to figure out which one of these is the best answer to represent the number of seals per year. It says the number of seals in the area in 2000 was 2,500. So let's do 2000. The year 2000 is right here. And the number of seals in that area was 2,500. This is 5 up here. So it's possible 2,500 is in the middle. So it's possible that that line of best fit, that this is the answer right here, because between 0 and 5 is 2.5. So this right here, it's a possibility that it could be 2,500, because that's the same as saying the 2.5, which is right here. So A is a possible answer. Okay, the number of seals in the area in 2001. So if I go to 2001, that's halfway in the middle between 0 and 2. And I need to go up to 400. Okay, so in the middle, 400. Ooh, wait a minute. Am I reading it wrong? 2000, 2001. That's 400. That is really close, because this right here could really very well be 400. Let me mark it. Let me see what they say here. Because we are talking about slope, so let's see. The seal population increased by 140 seals per year. Okay, this is more slope. This is more slope. So it's increasing by 140, or it's increasing by 2. Okay, so see, these are, even though they're both true, it's not talking about the slope though. It's not talking about the slope. So we got to cancel these out, because this is not talking about the slope. This is talking about the slope because it's saying it's increasing by something. So increase or decrease by something, that's when it represents the slope. So is it increasing by 140, Miss Reyes, or is it increasing by 200? These answer choices are so close to each other. All right, so let's see. If this is the starting amount right here, we could actually use these 2 points, because these 2 points are right. This point here is going to be 2.5, comma, 2,000. And this one could be 1. Oh, wait. The starting is 0. Why did I say 2 point? Why did I say that? I don't even know. This is 0, and this is 2.5. And this is 1, and this is, this is 4. Okay. All right, so we're going to use the slope formula, x1, y1, x2, y2. I don't know why they put those answers close together. I might need to make sure that they don't put those answers close together on that quiz. I didn't make the quiz on this one. This is one from the state. So we got y2 minus y1 over x2 minus x1. All right, so when this is the formula, what do we substitute? What goes on the top and what goes on the bottom? Very good, babe. What goes on the bottom? Dylan, what goes on the bottom? It's 1 minus the 0. These are your x's, okay? It's x2 minus the x1. All right. Okay. So what does that give me on the top? What's 4 minus the 2.5? What does that give us on the top? What does that give us? 4. See that? 1.5. So we got 1.5 on the top and 1 on the bottom. So this one is going up by 1.5 thousand, or if it's 1.5 thousand, so that's 1,000. Wait, why is it doing that? 1,000. It can't be. So no, that's not. I'm gonna have to look at this one because this is not right. These two aren't right either, but it's not written in terms of slope. Let's just forget about number 6, okay? Because that one's kind of crazy because that's not the right answer either. All right, skip it. What type of correlation mostly occurs between a person's age, so that's X, and the number of siblings? So that this is what it looks like. You got age is here, and you got siblings is here. So as age increases, does your age have anything to do with the number of siblings you have? Yes or no? No. So this is a no correlation. They don't have anything to do with each other. So that's a no correlation. Okay. All right. Number 8, the scatter plot below shows the number of hours studied and the grade on a test. Why? Okay. Using the linear model, what would be the best estimate for a student's score if the student did not study the test? So if they didn't study the test at all, they got 0 hours. Okay. So where would our line of best fit be? Somewhere in here, right? So one of these, the starting amount is somewhere in here. When they didn't study at all, this is when they didn't study. Okay, no study here. There's 0 hours that they studied. Okay, so what's the starting amount? So not 0. Mark that out because 0 will be way down here. Has to be somewhere in here. 30 is down here. So it wouldn't be 30. That's too low to draw a line. You see, that's too low. So it's not that one. I don't know why I went backwards. 50 is right in here. Ooh, that's a good answer. 50. The line could go in here somewhere. That's good. And then 70. 70 is up here. That line is, this point is too high. So your best answer is 50. Any questions about that? Okay. Yep. All right. Did you write it down, babe? All right. A teacher surveyed her class to determine the number of hours studied students studied for a test and whether they passed the test. Her results are shown below. So these are the results, okay? All right. So what is the percent of students that pass the test study for 2 to 3 hours? So this is how you write a percent. When you write the percent for these tables, you have to write it as a fraction first, okay? All right. So it's going to be, the fraction is going to be what you're looking for on the top and the total on the bottom. All right, so what am I looking for? I'm looking for the percent of students that pass the test that study for 2 to 3 hours. Pass the test and study for 2 to 3 hours. What number represents that? How many did that? Pass the test and study for 2 to 3 hours. What number is that? They passed the test. Say again. It's 9. Good. Okay. And I'm just looking at the percent of students that passed the test. So what's the total students that passed the test? How do you figure out the total students that passed the test? What numbers are you going to add together? What plus what? Huh? 3, 9, and 12. Very good. 3, 9, and 12. Okay. So let's add those together. You got 9, 10, 11, 12, and 12 is what? 24. So this is going to be 24. So now what do I do to figure out what this decimal is going to be? 9 over 24. What do I do now? Okay, you have to simplify or divide, okay? So what do I type in my calculator if I want to figure out what the decimal is here? What do I type? How do I type this in my calculator? So we're going to divide. We're going to type in the calculator 9 divided by 24. So 9 divided by 24. And that gives me this decimal, which is 0.375. Now, how do I change this decimal to a percent? What do I do to go from a decimal to a percent? What would you multiply by though? No. No. After you divide, you only thing you do to go from a decimal to a percent is to move the decimal over 2 places to the right. So this is going to be 37.5%. Do you see that? So if you have, Dylan, if I have 0.42, how do I change 0.42 to a percent? Which direction am I going to? Left or right? To the right. 1, 2. So what percent is this going to be equal to? 42. Do you see that? You understand that now? Okay. All right. So which one of these is the closest answer down here? Okay. So 37.5. Read your answer choices. 37. Huh? Say again. 38. Make sure you take your time so you don't get that wrong, okay? Okay. Number 10, the relationship between the grades on the test and the amount of time studied. This is X, this is Y. This is the time in minutes that a person studied, and this is their score. Okay, their grade in the class, when they study on the test or something. What is the meaning of the slope? Again, when you're finding the meaning of the slope, remember the y's are on the top, y2 minus y1, the x's are on the bottom. So when you read it, it reads like this. Your y is your score over your x is your minutes. So this is your score per minute. So you read it as your score per minute. Okay? All right. So that's what you do here. So my M here is 0.86 and my starting amount here is 36.59. So your starting amount is about 36. All right. So we're looking for the meaning of slope though. So let's look for slope. It says students do not study can expect a 36. This is very true. But again, they're talking about the meaning for slope. Okay. For every 10 minutes students study, they can expect their grade to improve by 8.6 points. Okay, so let's see what that looks like. Let's see if that's the slope. Remember, when you're writing the slope, M, your Y is on the top, your X is on the bottom. Here, your it says 10 minutes. Minutes is your X. That put that 10 on the bottom. Okay, that's X. See, it's minutes. Put 10 on the bottom. 10 minutes. They can expect their grade to improve 8.6. So points. So that goes on the top. 8.6. Okay. All right. So now we want to 10. They can expect their grade to improve. Let's see. Okay, let's see if this is going to work. Let's type this in and see what decimal we get. Let's do 8.6 divided by 10. I said 8.6 here. And yeah, that is the slope. Okay. Yeah, this is the right answer. B is the right answer. That is the slope. When you type in 8.6 divided by 10, this is what you get for slope, and that is right. Okay. 8 more points. In addition, study for 1 hour and can get expected grade. 1 hour is 60 minutes. So this would be 60. This would be 86. Oh, no, those are not right. Okay. So your answer there is B. Any questions about that? Okay. Dylan, are you okay? Okay. All right. A two-way table. Hector tracked the number of weeks different genres of movies were shown at a local theater. He recorded the data in the table below. Which statement best supported by the table? All right, so look, these are the different genres. There are comedy movies, drama movies, action, or other. A movie that doesn't fall in those categories, okay? All right, so it says for comedy and under fewer than 5 weeks, that's 3. This is 2, 3, 5. And this is, let's see, track the number of weeks different movies stay. So we only stayed for 3 weeks here. Okay, oh no, sorry. Uh, fewer than, hold on. Okay, sorry, y'all. Fewer than 5 weeks. So that means 3 movies stayed in the theater for fewer than 5 weeks. From 5 to 10 weeks, 5 movies stayed in the theater. More than 10 weeks, 6 movies fall into that category. Okay? Comedy. I love comedies. All right, so that's how you read the chart. So let's see which one is true. It says an action film. So let's look at action film is more likely to be shown for fewer than 5 weeks than a comedy. So let's compare. We got fewer than 5 weeks is this column. So, and we're looking at comedy and we're looking at action. They're the same, isn't it? Do you see that? So that's not it because they're exactly the same. Okay. A comedy is more likely to be shown for 5 to 10 weeks than drama. Okay, 5 to 10 weeks is right in here, and it's 5 movies here, and drama is 4. It's more likely to be shown for 5 to 10 weeks. Okay, yeah, this is a possible answer because it's 5 movies here and 4 movies here. So this is a possible answer. A movie shown in a theater is more likely to be an action film than a drama film. Okay, so how many drama films? Let's add these up. We got 4, 5, 6, 7, 8 here, and we got 3, 6, 8 here. It's the same. So no, it's exactly the same. All right. A movie shown at the theater will most likely be more than 10 weeks. More than 10 weeks. So a movie shown in theater is most likely. Okay, so more than 10 weeks. So the number is higher here. It's not higher here. It's not higher here. And it's not higher here. So no, not necessarily. Okay, so the best answer is going to be B. That's the best answer. That's the one that's true. Any questions about that one? Okay. All right. Okay. A cell phone company asks its customers that did not own a cell phone, did not own a smartphone, if they would like to upgrade the smartphone. Okay. The results are shown in the table below. All right. So let's look at it. What percentage, so we're doing percent again, of men wanted to upgrade to a smartphone? So we're just looking at men. We're just looking at men and how many of them want the upgrade. So remember, when you're writing a fraction, you're going to write what you're looking for on the top and the total on the bottom. Okay, we're looking for the amount of people amount of men, that want a smartphone. How many men wanted a smartphone? How many of them wanted to upgrade? 42. And we're still working with men and say people, it's just men. What's the total amount of men? How do we figure out the total amount of men? Nope. To what? What are you adding together? Say again. I'm sorry. I didn't hear you. Sorry. You add, okay, good. You add 42 to 28. Okay. Which will give you 70. Okay. Good. So you're going to divide. How would I type that in the calculator when I divide this? What do I type in first when I'm dividing that to convert it to a decimal? I type in 42 divided by what? 70, which will give you 0.6. Does that make sense? So remember, how do I change this decimal into a percentage? You move it 2 places to the right. And what am I going to put here as a placeholder? A 0. So what is this going to be? What percent is this? Say again, baby. 60%. Okay, so you got it? The answer there is A. All right. Any questions about that?